Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
One big project which is of interest is that in Australia, not only are we, installing solar and wind farms for local electricity, but we have so much sun and so much wind here that we could potentially export it to other countries. So in Northern Australia, there's actually a project proposal that's going to be the largest solar farm in the world. It's going to have the largest battery in the world, and it's going to have the longest marine or sub ocean cable in the world. And so what they're going to do is grow the electricity or create the electricity here in Australia, and it's going to be a cable running from Australia all the way to Singapore via Indonesia, and it could potentially supply up to 20% of all the electricity for Singapore.
That's just a small taste of what we have in store for you today. We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant atmosphere continuum. Today's guest is Dr. Michael Forster. Michael is a senior adjunct research fellow at Griffith University in Queensland, Australia, founder of Implexx Sense, and director at Edaphic Scientific, an exclusive distributor of meter group instruments. He obtained his doctorate in ecology and evolutionary biology from the University of New South Wales. He previously worked as an ecohydrologist at the University of Western Sydney and was a plant physiology senior adjunct research fellow at the University of Queensland. His research interests include plant-water relations and biomass allocation patterns at a macrophysiological scale, as well as experiments with sap flow. And today he's here to talk about applications of scientific instrumentation in environmental research, spanning from pollution monitoring on the Great Barrier Reef to assessing the role of wildfires on soil hydraulic properties, and a few other projects in between. So, Michael, thank you so much for being here.
Thank you for having me, and thank you very much.
All right. So as we do with our guests, we would love to hear a little bit of your background, your personal background, how you got into the sciences in general, how you got into ecology and environmental sciences, and what brought you to, where you are now.
Okay, so I suppose my journey is a story of increasing sophistication in using different technology. So when I was at university as an undergrad, my experience with technology was as much as a tape measure or a ruler. And then when I went to postgrad, I went up another level and started using a balance and some lights and this sort of thing. So, and then I started doing a postdoctoral program at the Western Sydney University. And there I was introduced to a whole range of different types of technology. So things like soil moisture sensors, weather stations, plant sensing technology. So yeah, going from something where I could barely have access to a tape measure to having really sophisticated scientific instrumentation was just fantastic. So, but when I first started university, entering as a freshman, if you like, I actually wanted to study birds. So I went to university to do a course in birds. But the year that I started was the same year that the professor of ornithology or the professor of birds happened to leave that year. So the course they offered in birds was no longer available. So they said, well, what else do you want to do? And I was really interested in biology. So I thought, I'll just do, I don't know, plants and whatever. And so you kind of, I never really wanted to do plants and I definitely never wanted to do soils, but it just started happening throughout university and it just became more and more of an interest. And the more I started doing plants and soils, the more interested I became in those topics. And the more I went down that rabbit hole and just got more and more into it. So it's sort of funny how you don't intend to do something, but life just takes you down different paths.
Plants are cooler anyway.
That's right.
Maybe not objectively.
Says a plant physiologist, right?
That's right. So yes, I went to did the postdoc, and we worked a lot of instrumentation there. And then I ended up starting my own business in 2015. So that's Edaphic Scientific, and that's basically an importation and distribution business. So we started working with companies like Meter Group, or back then it was Decagong Devices, and supporting companies like Meter Group in Australia. So one thing I'm very excited about with the business is we get to work with all sorts of different people and all sorts of different researchers and walks of life in all sorts of different applications. So not only soil and plant sciences, but we also do things like marine sciences and conservation and civil engineering and buildings and urban environments. It's just a whole range of different things, and it's very interesting, and it's what keeps me up and or keeps me going every day when I get out of the bed. And it's like what topic is going to be there in my inbox today? Like what are we going to be doing today? So you're never too sure, and it's always exciting to see what's coming up.
So then are you then getting to go out into the field? And I mean, I would assume that you're working with, the consultation side of things as well as the distribution of instrumentation. Are you then also, I guess, working with, installation and project setup and all those sorts of things?
So perhaps the most important role that our company plays, and probably you do too there at Media Group, is we help in the planning stage. So particularly big research projects, they have grand ideas. They want to do lots of different measurements, but in reality, everything's limited by the amount of funding that they can do, or the amount of funding that they can get for instrumentation. So one important step that we play is, okay, what sort of funding do you have, and what can we do to maximize sample size and get the best scientific outcomes for different research projects. So that's probably a lot of my time is spent in that planning stage of projects. I do some installations. I do get to go out into the field, and that's something I enjoy. I love getting out of the office and traveling to all different parts of Australia to have a first-hand experience with the projects. And there's also, once the data is being collected, particularly when there are students involved in the projects, we have a lot of assistance with the students to help them understand the data and analyze the data and what does it all mean and which directions they should go. So we don't really write research papers anymore, but we do certainly assist with particularly students in making sure they're understanding what the data is and that they're interpreting it in the correct way.
And that getting a project off to a good start and understanding the limitations of the instruments is, frequently the foundation of their project.
Mm-hmm.
Absolutely, and often too, some researchers aren't aware of what's available to them. So they might think, oh, I need to do this or I need to do that, and then you say, well, have you ever heard of this sensor or have you heard of this approach? And sometimes they're not aware of what's available to them. So making them aware of the different options out there is also an important part we can play in research projects.
And hopefully you don't get some of those grad students who say, "Hey, can you do my project for me?" I know Chambers has some stories. Chambers can tell some stories about people.
But it's also amazing when they get going and and are past that hump of, oh my gosh, how am I going to figure out this problem? Where do I even start? And so that's the amazing part from my point of view.
Absolutely, yeah. And I always have to put myself back into the shoes of being a grad student because I was at that stage at one point in my life as well. And it's like, well, okay, there was this time when I've never heard of a soil moisture sensor and had no idea what capacitance or TDR or stomatal conductance, any of these things, and I had no idea what they were. So, but one of the great things about working with a company like Media Group is you have fantastic resources on your website. So you have some really great webinars and educational resources, and I always direct students to those resources as a starting point. And sometimes they feel very overwhelmed, but it's always a great point to start. It's like, well, look, just go look at Chris at these webinars, or look at Doug or Colin or all the other guys at Media Group, and just start there and see where that takes you. And of course, the webinars lead to links where there's papers or other material, and it's just an ongoing process, and it just snowballs from there.
All right. Well, you mentioned in passing that you like to get out of the office and go explore all quarters of Australia there. That takes us into our first topic that we mentioned in the intro, where you've been able to help out with a research project looking at pollution monitoring on the Great Barrier Reef. Can you tell us a little bit about that project, how it got started, how you got involved with that?
Yes, absolutely. So for those who aren't familiar, the Great Barrier Reef is one of the seven natural wonders of the world. It's a massive ecosystem that sits off the sort of eastern and northern coast of Australia, and it's about 3,500 kilometres long, and it's one of the most biodiverse ecosystems in the world, and it's often compared to the Amazon rainforest in terms of its biodiversity. So it's an incredible natural legacy that us Australians have, but unfortunately, probably like most ecosystems these days, it's under a lot of threats. So the biggest threat it is facing is the accumulation of carbon dioxide in the atmosphere, which are of course are being absorbed by oceans, and that's leading to ocean acidification. The Great Barrier Reef is also under threat from invasive species like the crown of thorns starfish. But another big threat, which is not always recognized, but it's quite an important threat, is actually a lot of nutrients and sediments being washed off the land, and that's being washed over the Great Barrier Reef. So basically, particularly with the sediments, what's happening is after a tropical rainfall event or a cyclone or what have you, you get a lot of runoff going into the rivers, and basically the reef just gets covered in mud essentially, or a lot of dirt. So that's going to affect the water quality and the turbidity of the water, which is not good growing conditions for sensitive coral reef organisms. And the other big one too is the nutrient load. So with a lot of farming practices, they're applying fertilizer to their crops, so nitrogen and phosphorus and potassium and all these other fertilizers. And a lot of these fertilizers get washed off or they drain through the root zone into the groundwater. And then that then goes into the waterways, into the rivers and out into the ocean. And that nutrient enrichment can also affect the growth patterns of the Great Barrier Reef. So things like carbon dioxide enrichment, that's a global problem. That's something Australians, we can obviously do our part, but we don't have total control over that. The crown of thorns starfish or invasive species is something we can control, but particularly the sediment and nutrient pollution running off the land is definitely something we can control. That's the only thing that's completely in our power to do something about. So the Queensland government and the Australian government, they've dedicated a lot of funding and resources to understanding this problem and trying to work out, okay, why is it occurring? What can we do about it? And how can we resolve this issue? So um, all Australians, we love the Great Barrier Reef. It's not something people do intentionally. So even farmers and growers or land managers, they want to know what can we do to improve this situation. So one thing they have been doing, and this is where Media Group has been very beneficial, is using lysimeters to understand drainage patterns and nutrient loading around these farmlands and around the land that's adjacent to the Great Barrier Reef. So for those who may not be familiar, a lysimeter is basically a water collecting device or something that measures water in the ground. And in terms of the Great Barrier Reef, the two lysimeters that are mostly used are the wick lysimeter and the sampling lysimeter. So the G or the G3 wick lysimeter from Meter Group, it's basically a big cylinder that is usually sits below the root zone of a crop or of a plant, and water and nutrients gets collected into a reservoir beneath the root zone. So with this collection, we can measure how much water is draining beneath the root zone, and we can also collect that drained water, and we can measure it for nutrients and toxins, heavy metals, or whatever you need to measure. So we can take that solution back to the laboratory and measure for things like nitrogen and phosphorus. The other lysimeter, the what's called the SK20 sampling lysimeter, all that does, it just measures soil solutions. So you can put those samplers into the soil, and then you can collect the solution from the ground. So then you can measure your nitrates and phosphorus and what have you. So we have a lot of people actually installing the wick lysimeter, because you can actually connect that to the internet, and you can see in almost real time the amount of drainage that's going through the soil profile. So you can do that on a Zentra cloud platform. And you can also see with an EC sensor or an electrical conductivity sensor, you can also potentially see how much salts or nutrients are being accumulated beneath the root zone. So this is great information for growers, because they can after an irrigation or a rainfall event, they can actually see how much water is going beneath the roots of the crops. So as a grower, it's quite expensive to irrigate and apply fertilizer to your crops. So you don't want to be seeing all that wash right through the root zone and basically escape what the plants can uptake. So it's actually quite a lot of it's a good business model or a good economic model for farmers to sort of know how much water is being drained through the soil profile. And we can also see how much nitrates or phosphorus in particular are being lost through the soil, the root zone, and that's potentially going into the waterways and groundwater. So the wick lysimeter, it's actually a very popular instrument for this purpose. And it's also being complemented by the SK20 sampling lysimeters.
And rather than wait for the analysis to come back from the lab, like the suction cups, then you get with the electrical conductivity kind of a proxy of what's in there, huh?
Absolutely, yes. So obviously with the suction caps or suction cups, sorry, and the even the wick lysimeter, if you go collect soil solution, you're obviously only doing that at say once a month or once a week. So you don't really necessarily know when that water accumulated or when that event happened. So having sensors in the lysimeter, you can actually see, okay, when did the drainage actually occur? And with the EC sensor, you can kind of see, okay, when were the nutrients accumulating? So it's a great way to complement all the different data sets.
What have been some of the findings, at least with what you've been seeing? You mentioned, the runoff and the various nutrient load and other things like that are coming in. What else have you been seeing?
Or was anything surprising? Like
Yeah.
you kind of knew that things were running off, that you were getting nutrient loads, but what did the data show?
Yeah.
I suppose the surprising thing was there was nothing surprising. So it kind of confirmed what we knew already. And and also too in these areas, this particular part of Australia, the northeastern part of Australia is probably the wetter area of Australia. So water resources are not so limiting there. So a lot of growers have never really had the motivation to perhaps be more efficient with their irrigation or to look after their irrigation. So often they would just turn on the irrigation and let it run for a day or whatever it may be. So this is actually highlighting to them how much potentially over irrigating that's occurring, and particularly how much money they're wasting with the fertilizer and the nutrients, because it's getting more and more expensive applying fertilizer to crops. So that is definitely something that a lot of land managers and government agencies are trying to communicate to growers, is that even though you might not have a motivation to use water efficiently because you've got so much water, you should still be using the nutrient, the fertilizers a lot more efficiently to cut on your costs and to also have environmental benefits. So
Right. Right. Yeah, I was going to ask if one of the things that I've asked in with previous guests is how they communicate to various groups that they are working with, whether it is like you mentioned with growers or with government agencies or with researchers. Have you found I don't know, like a silver bullet or a, a golden ticket to be able to convince each of those to improve their processes?
well, I doubt it there's a silver bullet or anything like that. But one thing they do well, particularly in Queensland and other parts of Australia, all over Australia actually, is there is a lot of communication and a lot of workshops and working groups. And so people obviously don't like to be told what to do or dictated to. So there's a lot of consultation and working with farmers and growers. So there's definitely not a heavy stick going out there saying stop doing this, or we're going to tax you, or we're going to fine you, or anything like that. It's more raising awareness and then having regional workshops and regional educational days or field days and those sort of events, bringing attention to these factors. Because as I said earlier, most people in Australia don't want to have a negative impact on the environment. They do want to do the right thing, but often they don't understand their day-to-day practices are having a negative impact. So it's just sort of bringing that to their attention and saying, look, if you cut back your fertilizer by 10%, your crops are going to be fine, but you're going to be saving money, and at the same time, you're not polluting the Great Barrier Reef. So it's sort of a win-win situation, and that's the sort of approach most people like to take.
So, what do you see as the future then of this project? I mean, it's, as you mentioned, the Great Barrier Reef, over 3,000 kilometers long. It's a huge area. It's I doubt that this one single project is going to fix everything that's going on. But what do you see, yeah, as the future of this project and how it can help in remediation efforts and in revitalizing the Great Barrier Reef?
So one really positive aspect that's been occurring is that there's been a lot more land rehabilitation and regeneration, particularly with the sediment runoff and the nutrient loading or the sediment loading onto the reef. So often, say growers might have an area of their farm that they're not using, then they said, okay, look, we can plant a forest there, or we can revitalize a wetland, or we can do something like that. So they're looking at their land holistically and seeing how can we manage the land at a total landscape level so we can minimize the amount of soil and nutrients that are running off into the waterways. So not only is that helping or minimizing or decreasing the amount of soil and nutrients that's running into the waterways, but it's also improving habitat for the local native species. And there's been an abundance of evidence showing that when you have good biodiversity on or near farms, then that helps with other things like pest control and keeping insect population down. And so then you're not spraying as much for pests and this sort of thing. So it's sort of building more resilience into the landscape. And so it's building that kind of awareness. And it's definitely the direction where a lot of land managers and land growers are heading in Australia.
It is, like you said, yeah, one of the wonders of the natural world. And there's a lot of work that still needs to be done, though, to help it get back to its
Absolutely,
former
yeah.
glory, right?
Yeah, it's an ongoing thing. It's not going to stop tomorrow. It's something that we as if we're going to farm adjacent to the Great Barrier Reef, it's just something we're always going to have to keep in mind. So it's just an ongoing process and something we just got to keep improving.
Another thing that's quite common throughout the world is a push for renewable energy, and in doing that, generating or at least creating and developing solar and wind farms. And you've had a chance to work with instrument installations on some of these. Can you give us a little insight into how that's been going?
Absolutely. So this is a big topic in Australia, as it is probably most countries in the world. It's that transitioning from your fossil fuel sources like coal to renewable energy sources like solar and wind. And like a lot of places, the solar and wind is very abundant in Australia, but it's not quite where the populations are. So the best places to put a solar farm or a wind farm is often hundreds of kilometers away from our major cities or our major urban populations. So that means we need to also invest in a lot of infrastructure to transmit or transport that electricity. So that means installing a lot of cable, and particularly underground as well. So burying a lot of cable. So it sounds pretty simple and straightforward, but when you do bury cable, you have to keep in mind that it could potentially overheat. And once cable overheats, it can fail, and then that can lead to blackouts and brownouts and a compromise of the electrical infrastructure. So one thing that we do a lot here in Australia, or um, a lot of environmental consultants do, is they use the Tempos thermal properties meter and also the Varios thermal dryout curve device as well. So for those people who aren't familiar with these instruments, what they essentially do is they measure the thermal resistivity of the soil. So that they basically measure how heat is dissipated or is released through a soil or a substrate. So this is important because when you bury a cable, often around that cable you would have some kind of substrate or filling material that sits around that cable, and you need to make sure that the thermal properties of that material is not going to compromise the electrical cable. So they do a lot of testing in laboratories, and then they do a lot of in the laboratories they do a lot of testing with the Varios instrument, and then out in the field they use the Tempos instrument to make sure that the thermal properties of the substrate is correct and up to specifications.
And so do they have like different mixes, or I know very little about this topic, but I've seen some projects like that, so like what's their recourse if they find that the thermal conductivity is too low and you can't carry the heat load away?
So it's unfortunately we're not always privy to those details because because we're dealing with a lot of private companies here, they like to keep those their sort of their secret recipe and to themselves. So we're not always being told exactly what is their substrate or what is their secret formula, but there is definitely a standard where if you did lay a cable of certain specifications, then the thermal properties around that cable has to be a certain type. And importantly, not just the thermal properties, but the water content of the substrate as well, because the thermal properties of the substrate can vary with water content. And this is where an instrument like the Varios is very important because it tells you what is the thermal resistivity at a particular water content. So that's quite important to know. So we don't always know exactly what they're doing in terms of what substrates they're laying, but probably sometimes they're just laying it directly into the native soil. Other times they might have a particular geofabric or geo material that they're laying around the cable. So I would like to know, but unfortunately they don't always tell us these sorts of things. But they definitely, there is a industry standard or an industry table saying if your substrate is X, Y, and Z materials, then your thermal properties have to be this sort of these sort of values. So that's what they try to do.
And your role is to give them the information that they can meet those standards to have safe installation.
Absolutely. So our role in this particular instance is making sure the instrumentation meets industry standards. So there's a lot of what is called ASTM, and I know in Germany they have different standards themselves, and so all around the world they have different industry standards. So it's very important because when these consultants they lay the cable, they actually have to sign off at it and say, okay, we laid it to this standard, and the instrument we used was a Tempos, and the Tempos or the Varios meets this industry standard. So that's one great thing about working with Meter Group because you understand that there are these standards out there, and often you part of writing the standards yourselves. So we work quite closely with the industries to say, yep, we know what the standard is. Here's the documentation outlining the standards, and the Tempos and the Varios definitely meet those standards. So one big project which is of interest is that in Australia, not only are we, installing solar and wind farms for local electricity, but we have so much sun and so much wind here that we could potentially export it to other countries. So in Northern Australia, there's actually a project proposal that's going to be the largest solar farm in the world. It's going to have the largest battery in the world, and it's going to have the longest marine or sub ocean cable in the world. And so what they're going to do is grow the electricity or create the electricity here in Australia, and it's going to be a cable running from Australia all the way to Singapore via Indonesia, and it could potentially supply up to 20% of all the electricity for Singapore. So that project has been discussed about for many years. Yeah, it's amazing, and Australia is blessed with not only solar resources but also the space to be able to put all those solar panels. Um, so we can actually help our neighbors in Asia, where like Singapore, for example, is, land is at a premium in Singapore, so they don't have the luxury of installing massive solar farms. But we can install those solar farms here in Australia and export that electricity all the way to Singapore. So, and just to give you an idea, that cable is going to be about 4,500 kilometers long, which is probably what about the width of the United States. So um, something like that approximately. So that just gives you an idea of how long that cable is intending to be. So
that was actually part of one of my questions is that as they're laying cables throughout Australia, we're usually not that great at geography in the first place. But when we think of Australia, one of the things we think about is that huge central desert there, the outback. Is there much, I guess, diversity in the soil characteristics throughout that region. And I guess this is working with the assumption that that is where a lot of these solar and or wind farms will be located. Like you mentioned, it'll be kilometers, hundreds of kilometers away from the nearest town or city.
Yes.
So yeah, I'm just wondering about the soil characterization of that land there.
Yes, absolutely. So for those who aren't familiar with the geography of Australia, it's about the size of the continental United States. So the 48 continuous states in the US. So if you think of the size of Australia, it's roughly about that same size. And you're right, about 80% or about 75% of Australia is desert or an arid landscape. And so that means we have a lot of sunshine, but it also means not many people are living in the middle of Australia. So the population centres are mostly around the coast of Australia, and in particular on the eastern coast and the southern coast of Australia. So transporting that electricity from the sunny areas to those coastal areas does go through a lot of different soil types and a lot of different ecosystems and climates as well. So there is a lot of variety out there, and that is definitely something that has to be considered and managed when they're designing these projects.
Right, and that actually just triggered a thought as well. In many nations here in the United States and Canada as well, when trying to work on a project that size, you're also needing to involve consultation with indigenous groups as well. Is that something that then, I mean, we talked about in the last segment about working with farmers or growers and government agencies and researchers. How does that come into play with working with Indigenous Aboriginal groups there?
Yes, absolutely. So that is definitely a factor that needs to be considered and is being considered. So there's a lot of consultation, not only just the solar farms, but anything like mining companies and that sort of thing as well. So there's a lot of consultation and a lot of discussions with the local Indigenous people. But what's probably even more controversial, a lot of farmers are upset about all these transmission lines that are running through their properties. So that is quite a big controversy at the moment, that they don't necessarily want all this electricity or all this infrastructure, I should say, going through their landscapes. So that is a problem that probably not just us here in Australia, but probably in many places in the world, is this challenge of transitioning to these green technologies and having it dispersed right across the landscape and having to not only transport it, but dealing with all these different landholders and stakeholders and trying to get to a point where everybody's happy and everybody basically can have electricity at the end of the day.
Right. I know it's one of those things where I don't have an entrepreneur hat, but if I were to put one on, seeing that geography of Australia, there's quote unquote nothing out there, right? And there's a lot of sun, and it would seem like it'd be a paradise for solar farms. But at the same time, you have to deal with that cost benefit analysis of what then are we affecting, whether ecologically, environmentally, also working with various cultures and peoples that are there as well. I guess you don't want to create a giant heat island in the middle of Australia either, but yeah, so there's a lot that goes into working on projects like that.
Absolutely, yep. So on that topic as well, like there's not a lot out there. It's one big industry, or our biggest industry in Australia is mining. And even though we don't have a lot of dense population centers or dense cities out there, there's actually still a lot of economic activity in terms of mining. So some of the most sparsely populated regions of Australia are mine sites, and the Media Group equipment is actually perhaps a whole catalog that Media Group produces or manufactures is being used in the mining industry in Australia. And all the way from the planning stage to the operational to the closing down of different mining projects. So this is where Media Group has a big play or a big role in what we do here in terms of environmental management and environmental research in Australia. So when we're designing mines, for example, you don't design a mine for production, you actually design a mine for closing it down. So before you even start a mine, you're working out how do we close the mine, and what do we do with the land after everything's done? Because most mines are only around for maybe 30, 40, 50 years, something like this. So we need to know, okay, after the mine closes, what happens then? And so there's a big, basically any mine that gets approved now has to have a plan for closing it down. And the goal, if you like, is to return the landscape back to its natural form or back to what it was before the mining started. So it's probably a bit idealistic. If you dig a big pit in a landscape, it's probably not so easy to return that to exactly what it was before. But there is I guess, a motivation that a lot of mining companies and a lot of the community want to see that being returned to something that's, can be a national park or can be like you look at it in 50 years time and you would never think there was a mine there. So the media group equipment is used to, for example, the WP4C and the high props. They're used to work out the soil water characteristics when you're planning for different mine sites. The things like the PARIO for particle size analysis, we're working out what are the soil characteristics, and things like the SATURO or the KSAT are working out the hydraulic conductivity and the infiltration of the soil properties. So there's a big understanding, okay, what are the soils doing at these sites? What are they, how are they behaving? How do the different plant species there, how do they tolerate different hydraulic conductivities and particle sizes and this sort of thing? And so there's a lot of equipment's being used in that respect. So then when the mine actually gets closed down and they're planting forests and they're planting vegetation.
Sounds like the type of measurements they're making are more to understand how water will move through the soil. Then is that to it kind of
Absolutely, yeah.
At the restoration end, so that they can kind of build it back up, or is it to keep like extraction pollutants to understand where those are going to move to and contain that sort of thing?
So it's probably all of those things. So water in the landscape is very important for mining. So not only extracting it for different mining processes, but also to minimize the amount of pollution that you could be causing in the waterways. And one particular world studied or world thought about process in Australia is these ecosystems called groundwater dependent ecosystems. So these are basically forests that are growing out in the desert, and there's just looking at it, there's no water or anything out there in the desert, but you've got these nice, beautiful forests and vegetation growing out there. And they're actually accessing water from the groundwater, so about 40 meters below the surface. The roots are going that far down into the ground, and that's where they're getting their water from. But if you put a mine site right next to that, then that's going to affect the water level, the groundwater levels. It could go up, it could go down. So there's a lot of people monitoring the groundwater and monitoring the vegetation itself to make sure that the amount of water that's extracted or the amount of water that's being put back onto the landscape is not affecting these groundwater dependent ecosystems. So things like the Terrace 21 soil water potential sensor, especially, those sensors can show that say the top 1 meter is completely bone dry and absolutely not a drop of soil, not a drop of water available to the plants at all. But you have this beautiful vegetation community still growing there. So those sensors can demonstrate that there's no water in the top, but the plants are obviously growing, so they must be getting it from the groundwater. So that's just one example where the media group sensors are being used quite a lot in the mining industry is these groundwater dependent ecosystems.
Get a bit of your ecophys hat going with that project, huh?
Oh, absolutely. So it's a wonderland for ecophysiologists or ecohydrologists. It's you have a lot of research projects. So they not only can do research projects to benefit mining, but you can also address fundamental questions of ecophysiology and ecohydrology. It's a great complement, not just to do land management or ongoing monitoring, but you can actually address fundamental research questions as well. So,
as we're talking about landscape and working with groundwater, let's talk. I guess we can keep talking about soil hydraulic properties, but we want to touch on wildfires and their role in I guess, soil hydraulic properties of the landscape. I know we have quite a few different, several of our customers here who are researchers looking into this very issue. I know Australia has had its large wildfires, especially a few years ago, a huge one. So can you give us a little background into what's going on with those kinds of projects there in Australia?
Sure, absolutely. So, yeah, as you mentioned, wildfires are particularly important here in Australia. So, locally, we call them bushfires. And you might remember a few years ago, just before COVID and before the pandemic, we had a horrendous fire season where um, billions of animals died and millions of hectares were succumbed to wildfire. So that was a very, very bad wildfire season, or bushfire season, as we call it here in Australia. So we need to understand, okay, so we have these wildfire events and how does that impact the landscape? And so obviously when you have these really high intensity bushfires, it basically strips the whole land of vegetation and root matter and things like this. So you just have all this loose soil just sitting there on top of the landscape. And often after a bushfire event, you get a heavy rainfall event. And this can cause a lot of erosion and it can cause a lot of sediment running into creeks and rivers. Not only that, but we need to understand that when you have these big fire events, that it actually changes the physical and chemical structures of the soil. And this in turn can impact the infiltration rates and hydraulic properties of the soil. So the species that naturally grow there and need to regenerate might be affected by the change in chemical and physical properties caused by the fire. So it's a bit like a fire cooking the soil, and just like we cook chicken or a steak or vegetables or whatever, it changes the chemical composition. It's the same with wildfires and what it can do to the soil. So instruments like the Saturo and the mini disc infiltrometer, particularly the mini disc, that is really popular for this because it's so small and tiny. You can put it in your backpack and you can go hiking around the landscape and do lots of measurements all over the place. So a lot of research is being done with those sort of instruments to understand the hydraulic properties of the soil and how these change after different fire events.
What are some of those changes? What have you or those that are doing that research have been seeing, whether using the Satro or other infiltrometers?
So as I mentioned before, the structure can change. So the physical structure can change, and you can get more repellency in the soil. So or the soil becomes a bit more hydrophobic as well. So rather than rainfall events being able to seep through the soil and naturally go down a profile, you could get the soil becomes hydrophobic and it repels the soil and it starts running off. So you don't get that infiltration, particularly down into the deeper parts of the soil profile. So this can obviously then have ramifications for what type of vegetation can regenerate or regrow in areas that have been succumbed to fire events. So, so through these measurements, you can start to better understand, okay, how intense was the fire? How did that change the infiltration rates? And in turn, you can do, say, glasshouse or laboratory experiments and say, okay, if we have this sort of infiltration rate, what sort of seeds can regrow under that? Or which sort of species can tolerate that sort of soil environment? So there's so many things to unpack there, and there's so many different results that you could look at, and it's definitely not one result that answers everything across the landscape. It's very heterogeneous response, particularly as well where on the landscape it occurs. So if you're at the top of a slope or on a plateau, or if you're midway down a slope, or if you're down in a valley, the physical structure can also change, and that can affect the infiltration rates. So looking at different parts of the landscape and particularly slopes on a hillside, and how that can change the soil properties as well. So there's so many things that can occur after a fire, and there's so many things we're still trying to understand that it's hard to say. Well, you just can't say this is one result across the whole landscape. So there's just so much to understand there.
Is it something then that I guess it's not so much that they're trying to. I'm just thinking about remediation efforts, and it's not that they're trying to get things back to the way they were, but it's more so what can we do now with the soil characteristics that are there now, the soil properties that are there now, to, like you said, revegetate or revitalize that landscape. Is that more of the case?
I think that would be nice if we could do that, but it's such a big landscape and such a large area that it would be very difficult to implement any sort of management strategies to change the landscape in that way. So it's probably more trying to understand how is these wildfires and how are these big fire events, how are they changing the landscape and how is that going to change the species composition? So it's more of a reactive understanding. So I mean, sure, it'd be great if we could be proactive and apply some kind of chemical to change the structure of the soil to help the infiltration rates or something like that. But, we're talking vast, vast areas here that it's just really not practical to, there's just not the money or the funding to do that sort of management, that land scale style management. So it's more of, okay, these fire events are going to happen. If we get a fire event of this intensity or this extent, how is that going to change the landscape and how is that going to change the composition of the vegetation coming back? And um, probably the only thing we can do and something that's becoming even more difficult to do is change the fire regimes ourselves. So you mentioned earlier about Indigenous consultation, and before Europeans arrived into Australia, the Aborigines were masters of using fire. And of course, when Europeans arrived, we told them to stop using fire, and the whole landscape just became a complete mess. And it's taken us more than 200 years to understand that, okay, these guys actually knew what they were doing, and maybe we could learn a thing or two from them. And so, particularly since those really bad fire season a couple of years ago, there's a lot more consultation with Indigenous people and what they call cultural burning and incorporating Indigenous knowledge about different fire regimes. So there's been a lot more push or a lot more appreciation of using those techniques. So I think understanding, okay, if we have these big, nasty, massive, intense fire events, that's going to cause these really bad landscape changes. But if we use the cultural burning or the cool fire events, that's more done on a very local scale and not such an intense area, then that's not going to have a negative impact on the soil structure and the subsequent vegetation. So that's where incorporating all these different types of measurements can really improve our understanding and incorporating different management techniques into the landscape.
Are there measurements that might be helpful to identify high risk areas and kind of predict when we're going into these high fire seasons? There's we have a similar problem in the west of the U.S. and it seems like there's efforts to kind of um, understand like when we're at our peak risks or if it's a little bit less or identify areas that are higher risk. But there's still a lot of work there to do. And is there any movement towards that in Australia?
Yes, absolutely. So yeah, it's a big research area, and there's a lot of different fields of science and inquiry in that. And we actually do work very closely, particularly in California and other parts of North America, um, because one advantage is our fire season is at the opposite time of the North American fire season. So often when we have a very bad fire event, we have people from North America come down and they learn from us and we learn from them, and vice versa. During your bad fire season, that's our cool time where we don't have fire. So we have teams and researchers go over to North America to learn from you guys, and so there's a lot of collaboration around the globe. It's definitely a lot of good local knowledge, but there's also a lot of things we can learn from each other. And also in areas like Greece, for example, in Europe, they've been having some very bad fire seasons recently, and Spain and Portugal as well. So I know some of our fire experts are going over there to not only offer some advice, but also to learn from them, which and to bring that knowledge back to back here as well. So there's definitely a lot of collaborations and a lot of sharing of knowledge. And I think that's the only way to move forward as we, not only us here in Australia, but all over the world, we try to manage this problem.
Let's move on to our last subject here, and I think this one it will harken back to a younger Michael Forster from several decades ago who was interested in birds, and we wanted to talk about monitoring endangered birds and frogs and what's been going on with that and how you've been involved with those kinds of projects.
Yeah, absolutely. So as I said earlier, one of the exciting things about what we do is you never really know what project you're going to be doing next. There's such a variety of things to do, and yeah, you're never sure what's going to end up in your inbox and what you have to deal with that particular day. So one thing that I still get excited about is working with animals like birds and frogs and bats as well. So even though the media group equipment is promoted as plant science or soil science or atmospheric science, they're still used quite a lot for animal management or animal understanding animal ecology. So one great example is what's called the white-bellied frog, which is found in a very localized area of southern Western Australia. And this particular frog, it's only about 2 centimeters in length, so it's very, very small. And it's only found in very specific drainage lines in this one specific part of the landscape. So as you can imagine, it's because it has a very specific habitat, it's under threat. And so researchers want to understand, okay, how does it breed? What is its breeding behavior? How can we improve it? How can we help this species? And so one thing they did, they used the Teros 21 soil water potential sensor to measure the soil properties around where the frog is living. And because the frog also buries itself into the soil to get some moisture. And what it actually found was the optimal water potential for the soil is about -11 kPa, and the optimal temperature was around about 15 to 18 degrees Celsius. So at those temperatures, that's when the frog was most active. That's when it was calling a lot for breeding events, and presumably that's when it could was at its happiest and could breed and propagate the species. So using a soil sensor, we can use that to understand frog breeding behavior. So something like that is really cool. And when those researchers come to us, like they've probably never done soil science before, but they kind of know it's important. So that's where we can really assist them in the planning and helping them with the design of the project in this particular sense. So another great one as well is what's called a ghost bat, or it's also called a vampire bat. So it sounds very ominous and sounds like something you wouldn't want to come across, but it's a beautiful bat species. It's kind of like this white color, and it looks like something out of a horror movie if you kind of came across it. But they live in these caves across northern Australia, and again during their breeding periods, they have very specific microclimate requirements. So the temperature and humidity in the caves need to be a specific level where they're happy to breed and procreate. So in these particular projects, the Atmos 14 sensor, which measures air temperature, humidity, vapor pressure, and barometric pressure, a lot of these are installed in caves to monitor the temperature and humidity for these bats to ensure that their breeding events are occurring at an optimal level for them. So that's pretty exciting. And the last one you mentioned as well about the birds. So this is a great one because it's down in the just off the Southern Ocean. It's where the what's called the shy albatross. It breeds on some islands down in the Southern Ocean, and what they're doing down there is they want to understand the weather patterns and the microclimates around these islands. So they've installed the Atmos 41 weather station on these islands basically down in the Southern Ocean. And through the Atmos 41, they're getting a better understanding of basically the climate that these albatross are breeding and living under. So we don't know a lot about these birds, or we're still learning a lot about these birds. So we don't know, do they have an optimal temperature? Do they have an optimal wind? Do they have an optimal humidity or whatever it may be? So we're using the media group equipment to understand these environmental factors to better understand endangered species and their breeding patterns, and how to better manage them for future people.
When you have a new project and like what are your, or just looking back, like what are some of your favorites? I mean, I know you mentioned like a lot of these, this could be like your hit list, but what are your most exciting things to work on, like when you get that call and it's like, I don't know, looking back, what are some of the things that you enjoy most about
Yeah, well, that's a hard one to answer because we get so many different projects and they're all interesting, and that's the thing. Like every researcher, they're so dedicated to their work and they're so passionate about their work that we have to show respect to them, and we have to show them the same amount of passion and excitement about their work, because it's all, even though most researchers or most people think what they're doing is the most important thing in the world, I think what everybody's doing is really important, and we're all contributing to the greater good. Um, but having said that, like, yeah, I really enjoyed the like ones that are a bit unusual, that you might not expect equipment to be used in a particular way. So the one with the frogs and the Teros 21. Now that it's been done, it's sort of obvious. It's like, well, yeah, of course you could use the Teros 21 for such a purpose, but it's not something that you would promote on our website, or something you would go out to say to people, oh, you need a Teros 21 to measure your frogs. So something like that is always exciting, and things like the WP4C, for example, like traditionally that's used to measure the water potential of soil, but people use that to measure water potential of leaves or coffee beans or materials, or all sorts of different things. So using your imagination to take a sensor or a meter that's used for one thing to do something completely different. For me, they're probably the more exciting things, that you're thinking outside of the box, and you're thinking of different ways to use tools for different purposes. So.
like, hey, water content might be really important here, even though it hasn't been measured that much in this situation. So yeah, those are the kind of my favorites too. It's like
those fun different applications that you really don't show up.
Study like the decomposition of dead bodies.
That's right. Yeah.
Like, cool.
We want to make sure that those chemicals from decomposition don't go flowing into the groundwater and those kinds of things. I think we're at the end of our time. I think it would be great to have you on again, Michael, so you can talk more in depth about your sap flow experiments. I know that's something that you've worked quite a bit on, and have instrumentation specifically for that kind of research. So I think we'll need to save that discussion for a deeper dive at another time. Our time's up for today. Thank you again, Michael, for being with us.
Okay, no worries. Thanks very much. It was great talking to you, and it's been a pleasure, and any time. So yeah.
It's been a great
Michael.
Conversation. We'll see you later, Michael.
Talk to you later.
Thank you again.
And if you in the audience have any questions about this topic or want to hear more, feel free to contact us at metergroup.com, or reach out to us on Twitter at meter_ENV. And you can also view the full transcript from today in the podcast description. That's all for now. Stay safe, and we'll catch you next time on We Measure the World.